Hi everyone, welcome back to math classes, and today we are going to discuss about the exponential function. Any function which has an exponent is called an exponential function, and its general format is, as we know, this is the general format of an exponential function. F of x is equal to a b to the power x. For example, if we have fx is equal to 3 to the power x, 2 times 3 to the power x, and this 3 is called the base of the function, and that should always be a positive number and not equal to 1. And this number before that is called the constant. That constant is called denoted by a, and a is any non-zero real number. It can be positive, it can be negative, but not equal to 0. If it becomes 0, then doesn't make any sense because the whole thing becomes 0, right? Now look at the GeoGebra here. I made a graph of that a to the power x, where a is the base here actually, and I made a slider for a, and the slider value is going to change. So look at that one. Now the slider value for the base is 1.1. So if I change that base as b itself. So now we can see the slider value is going to change. The base value is going to change from 1.1 to, see, it's 2.1. Now the graph changes, right? Now I'm slowly moving the base value. See, you can see that what happened to the value. As the base value increases, the graph leaning more and more and more and more towards the y-axis. So the base value increases, the value of the function increases. See, and the base value decreases, that value is the function is decreases. See, you can see the function, the graph of the function is wider and wider and more and more and more wider. So that's in if the base value is greater than 1. And what if the base value is less than 1? See, look at that one. See, now it's 1, so it's a straight line. And if it is less than 1, so it is decreasing like anything. See, it's the going downward. So as it is going downward, it is called a decreasing graph. So when the base value is in between 0 and 1, then that function is, the exponential function is actually a decreasing function, and that's why it is called decay function. And if it is going upward, it is called an increasing function, or exponential growth and exponential decay. So here in the graph, you can see that the a value is the b value, the base value is increasing from here to here to here, and then the sharpness of the graph, then the thickness of the graph is increases. That means the graph leaning more towards the y-axis. So when the base value, the b value increases, the function becomes more and more and more bigger. That's why. And this a value means if we multiply with another one, then it is again leaning towards the y-axis. So that is called this a is called the growth factor, and b is called the base. And if the b value is in between 0 and 1, means in between 0 and 1, it is called an exponential decay. For example, this is the graph of 1/2 to the power x. So we know this b value is a number which is less than 1, that is in between 0 and 1. So that means it is an exponential decay. And if the b value is greater than, for example, it is 2 here, so it is 0. No, it's greater than 1, so means it is b value is greater than 1, in between 1 and anything can be. So if it is greater than 1, then that value is called, that function is called an exponential growth. So that's why if b greater than 1, it is an exponential growth, and if it is the base value is less than 1, it is called an exponential decay. Got it? Now look at the graph. If I add a number to this one, say for example plus 2, what happened? So if I add a plus 2, then the graph will go 2 units above that, right? So if I add a number to that thing, so I will do that one more time. See, look here, this is negative 1.6 to the b is the base is 1.6 to the power x. Now I'm going to add a 2 to that one. Then if I add a 2 to this one, then this will shift 2 units upward. Same, plus 2, so that's why it is plus 2. So if I am going to add a plus 2, you know, it will move 2 units upward. See, yeah, if it is 2 units. And if I, instead of that 2 units, if I add 3 units, then you can see that will move 1 more units up. So when we increase the value of that thing, if I add a constant to that thing, then the value increases. You can see if I move slowly moving that value, you can see that the function is moving upward. So that means that value will move up and down when we change the value, adding something. So that means it is the vertical shift. Okay. So look at the graph. If we add a 5, then the original graph is 2x, fx is equal to 2 to the power x, and its the y-intercept is at x is equal to 1. And if we add 5 units, then plus 5 will shift that graph 5 units more. Means the from 1, the y-intercept to 1 is changes to 6, because 1 plus 5, that means it moves 5 units upward. And if we subtract that, then automatically that will go 5 units downward. So when we add or subtract something to the function, means f of x is equal to, say, b to the power x, and we add something, then say k, then it will move upward. And if we subtract something, it will move downward. So this is what is called the vertical shift of the graph. Okay. Now we are going to find out the equation of the graph. We are just given a graph, and we are going to find out the equation of the graph from the graph itself. Okay, if we look at the first round, this is called the first one, and this is the first one. And if you look at the graph, we can see that this is the general format of or toolkit function of a exponential function. So we can take it as b to the power x, b to the power x. Okay. Now we want to find the base value. So how to find the base value? So for that we need to find out 2 points. So what happens when x is equal to 0 here? When x is equal to 0, we know the y value is 1, right? So when x is equal to 0, the function value is y value, means f of x is equal to 1. And when x is equal to 1, it is 4, right? So 1, it is 4. So that means if we have the f of x is equal to b to the power x, and when x is equal to 0, x is equal to 0 means b to the power 0, that is equal to 1. So that is obvious, that is correct. And then when x is equal to 1, b to the power 1 is equal to 4. That means it is 4 to the power 1. So b is equal to 4. Right? So we can see that the function, we can deduct that the function's equation becomes b to the power x. That means b is equal to 4. So 4 to the power x. Make sense? Then we can verify that when x is equal to 2, what happened? So when x, if b to the power, so 4 to the power x is the function, then x is equal to 2, it becomes 4 square. So x is equal to 2, it will 4 square is 16, and we can verify that when it is go upward, and it will meet at 16 there. Yeah. So the equation of the function is, the first graph is 4 to the power x. Make sense? Okay. We can apply the same thing for the second function. So it is of the form, again it is of the form b to the power x. When x is equal to 0, it is always 1. So when x equal to 0, b to the power 0, that is equal to 1. So that is correct. when x is equal to 1, means b to the power 1 is equal to, x is equal to 1, we can check the graph, it will meet at 2, right? So it is 2, means 2 to the power 1. That means b is equal to 2, right? So the equation of the graph is b to the power x, that is 2 to the power x. Okay, so actually what we are going to do is we will check what value of b to the power 1 will give you the y value. So when my x is equal to 1, it is 4, so b is equal to 4. When x is equal to 1, b is equal to 2, so it is 2 to the power x. Got it? So that is the way. So because it is the b to the power x and b value will be greater than 1. And another one. So this is the first one, and in this first graph, it is a decreasing function. So again, the equation will be b to the power x, but the b value will be less than 1, means in between 0 and 1. To find that, when x is equal to 0, we know this is always equal to 1. So that is b to the power 0 is 1, so that is correct. Then we want to find the b value. To find the b value, in the increasing function, we look for x is equal to 1. For the decreasing function, we look at x is equal to negative 1. So when x is equal to negative 1, it will meet at 5 here, right here, 5. So when x is equal to negative 1, means b to the power negative 1 is equal to 5. So what is the meaning of b to the power negative 1? 1 over b. So 1 over b is equal to 5. That means if we flip both sides, we will get b over 1 is equal to 1 over 5. So b value is equal to 1 over 5. So in here, f of x is equal to, the equation is b to the power x, and b is 1 over 5. So it is 1 over 5 to the power x. So that is the equation. Got it? So for an increasing function, to find the b value, we will look at x is equal to 1. And for a decreasing function, we will look at x, what value will be the value of the function when x is equal to negative 1. And we can do the second one also in the same way. For the second one, again the same one, y is equal to b to the power x. When x is equal to 0, it will be 1. That is true. B is equal to 0, it is 1. And when look at the x is equal to negative value there, negative 1, it will meet at 2 there. So b to the power negative 1 is equal to 2. That means 1 over b is equal to 2. Flip both sides, we will get b is equal to 1 over 2. So the graph is b to the power x is equal to 1 by 2 to the power x. So that is the equation of the graph. Got it? Now we have one more problem, that is how to draw the graph of 4 to the power x. Just like in the previous case, when first one, 4 to the power x, we want to input two values. For x is equal to 0, we have to find x is equal to 0, it will be 4 to the power x. So 4 to the power 0, that should be 1, right? So when x is equal to 0, it should be 1. When x is equal to 1, it will be 4 to the power 1. So 4 to the power 1, that is 4. So 1, it is 4, right? And when x is equal to 2, it will be 4 square and will be 16. So it will meet, when x is equal to 2, it will meet somewhere there here. So we can draw the graph like this. This is the graph of the function. Got it? That is 4 to the power x. Okay? It is 4 to the power x plus 2. And what happened when x plus 2? It will move 2 units upward, right? So from here, it will move 2 units upward. So it will meet here. And so if you want, you can put that value here. X, 4 to the power x plus 2. When x is equal to 0, it was originally 1, but it becomes 3. and when x is equal to 1, it will be originally 4, but it becomes 4 plus 2, 6, right? So when x is equal to 0, it is 3, and x is equal to 1, it will be 6. So we can draw the graph like, see, like this way. Okay, and for the third one, 2 units to the right, okay, because it is the horizontal shift. When I am going to give x is equal to 2 here first. Why I choose x is equal to 2? Because I want to convert the power to 0. So it will be 4 to the power 2 minus 2, and that will be 4 to the power 0, and that's equal to 1. So when x is equal to 2, it will be 1. See? And now I am going to give x is equal to 3. When x is equal to 3, it will be 4 to the power 3 minus 2, and that will be 4 to the power 1, it's equal to 4. So when x is equal to 3, it will be 4. 3, it will be 4 here. So the graph will be like this one. Got it? Okay. And again, we can have the values here. X value 3 to the power x plus 5. And I'm going to choose x value such that the power becomes 0. For that, I want to choose x is equal to negative 5. So it will be 3 to the power negative 5 plus 5. So that becomes 3 to the power 0, that's equal to 1. So when x is equal to negative 5, it will be 1. Okay. When x is equal to 6, I mean negative 4, because I want to pick that 3 to the power 1. So that's why I choose that for negative 4 plus 5. So it will be 3 to the power 1, that is 3. To get the power of 1, I choose the x values like that. First of all, I want to get x is equal to 0 there. The top value will be 0. And then I want to get the power in the exponent as 1. So that is why I choose the x values negative 5 and negative 4. When x is equal to negative 4, it will be 3. So it will be somewhere here. So the graph will be like this way. Make sense? That's it. We know if we assign a negative sign to that function fx is equal to 2 to the x, and if we apply a negative sign, it will be reflected over the x-axis. So if we apply a negative of that one, it will be a horizontal reflection, and if we apply the negative sign to the index value, that will be a reflection about the y-axis. So f of x is equal to b to the power x is the original function. Then if we apply minus of f of x, means minus of b to the power x will be the horizontal reflection, means a reflection about the x-axis. And if we apply a reflection about the x value only, means f of x is equal to b to the power negative x, then that will be a reflection about the y-axis. So that's all about the exponential function. Hope that makes sense. Thank you. Have a good day.